Okay, for section 1.4, we are going to be dealing with a concept called direct variation, which will lead right into something called proportion. And these are things I think you've seen before. By the end of this lesson, you should be able to write and apply direct variation equations and solve proportion. And I think this lesson should be fairly on the easy end for you guys, okay? So let's get going on this one. I'm going to talk a little bit about what direct variation is. Well, the variable y varies directly as x if there is a non-zero constant k such that y equals kx, k times x. The equation y equals kx is called, check this out, check out what it's called, direct variation equation. Okay, and the number k is called the constant of variation. Okay, why do they use a k and not a c? I don't know, but that's what it is. And here's an example of things that vary directly in the real world. For example, one example is the longer you drive, the further you go. So there's a direct variation. As you drive longer, something else increases. You go farther, right? This is what I'm working on right now. The more I eat, the bigger I get. I gotta slow down on that one because there's a direct variation there. You can't eat so much. Think about some other direct variations out there. There's tons of them in the real world. Spend more money, you get more things usually, right? If I go to Chipotle, I spend $20. Now I'm dealing with getting 3 burritos, which goes back to my trying to watch my weight as I eat more. So we're going to use this idea of direct variation down in this first example. And what it's asking us in this one is to find the constant of variation k and the direct variation equation. If y varies directly, they're telling you it varies directly as x, and y is 24 when x is 4. So what's nice is this is a pretty easy problem. Check this out. What we got to do is you got to take the y equals 24 and plug in for this y. And then you got to take the x, no, here it is, the x equals 4 and plug in for that x. And then once you plug it in, you're just going to solve for this k. So what we have is let's do this in green. So you have y, which is, oh gosh, what am I doing? This is all wrong. Okay, so we have y, which is 24, right up here, is equal to k times our x is 4. Okay, now we got to solve for this k, so we got the railroad track method. We're going to divide both sides by 4. Why am I dividing? Because this is multiplication. To undo multiplication, you got to divide, right, everyone? Undo multiplication, you got to divide. So that 4 cancels off that 4, and we have our k. Our constant of variation is equal to 24 divided by 4. I'm pretty sure that's 6 last I checked. So k is equal to 6. So we figured out what our constant variation is. Now we just have to make the equation back up. So we're going to take this 6 and just plug it back in for our k. So our direct variation equation is y is equal to 6x. There you go. So we're going to deal with some other problems just like this. The next one's going to be dealing with one of the fastest men on our planet, Usain Bolt.